Welcome to the first day of Summer General Physics. In this fifth video, we'll be looking at significant figures and estimation. So take a look at this slide and ask yourself the question, how long is the chocolate bar? Inspect the picture and pause the video and choose your best answer. Okay, now that you've selected a response, let's take a look at this picture. As you can see, this is not an easy question to answer. The end of the chocolate bar is kind of lumpy and our ruler isn't terribly precise. So it's easy to see that it's about 4.4 centimeters, but that last digit's a little questionable. So really any of these responses would work. The point of this question is to realize that whenever you're taking a measurement in the real world, the thing that you're measuring, there may be inherent uncertainty in what you're measuring, but also in your measurement apparatus. And it's important to take that into consideration when you're recording numbers or reporting numbers. Often when students do a calculation, their calculator gives them a whole bunch of digits, and the temptation is to write all of those digits down, but they may not all be meaningful. So this brings us to significant figures. As we've seen, all measurements involve some inherent uncertainty due to the thing that you're trying to measure and your measurement apparatus. And so we have rules for how many significant figures should there be? How many digits do we write down? And if we do calculations with those digits, how many should be written down as the result of that calculation? So the rules for addition and subtraction, it turns out, are different from those of multiplication and division. So for addition and subtraction, if you're doing some calculation and you know how many significant digits you have for each of the numbers that you're adding and subtracting, what you'll do is first line up the numbers that you're adding along the decimal place. And then after you've added the number, you figure out what is the smallest, what's the smallest place that both numbers have in common. In this case, it's the hundredths place. And so your answer should be rounded to that smallest decimal place. On the other hand, if you are multiplying or dividing two numbers, then your answer should have the same number of significant digits as the smallest number of significant digits in any of the numbers that you're multiplying or dividing. So in this second example, we can see that we have this number, the 0.012, which has 2 significant digits, and this number, which has 4 significant digits. So our answer should have 2 significant digits. Now, you may not have guessed that the 0.012 had only 2 significant digits, and the 1.630 had 4. It seems like we're treating the zeros differently in both cases. And it is true that when we are trying to figure out how many significant figures are in a number, that zeros can be a little tricky. So the rules, it turns out, are different for zeros that are to the left and right of the decimal point. The big principle to keep in mind is that if a zero is necessary to tell you how big a number is, then that zero is not significant. Its job is to tell you how big the number is and not to specify accuracy. If, on the other hand, the zero is not necessary to tell you how big the number is, its job is to specify accuracy and it is therefore significant. So let's look at some examples of that. Here we have 120 written down, and this zero in the first 120 that's written here at the top, this zero is necessary to tell us that we have 120 and not 12. If we left it off, it would be a different sized number. So since that zero is telling you how big the number is, that's its job and it is not significant. On the other hand, the 0 to the right of the decimal point here is not necessary to tell you how big the number is. If you left it off, you would still have 120. So its job is actually to specify accuracy. you're saying that you have 120.0 and not 120.1 or some other number. So since you are specifying accuracy, then this 0 is significant as well as the 0 to the left of it. So this number would have 4 significant figures. Now, if you have 120 and you want to specify that the 0 in the ones place is significant, then the way you would do that is by putting a decimal point after the 0 so that you have 3 significant figures. Although by far the clearest way of specifying significant digits is to use scientific notation. So here we have 1.20. The 0 is significant, and it's clearly significant because it's not necessary to tell you how big the number is. It is specifying accuracy. So it's a bit easier to tell when you have scientific notation that a number is or is a 0 is or is not significant. So over here in the right column, we apply the same principle. So when we are looking at the number here in the middle, the 0.012, this 0 and this one as well are not significant because this 0 is necessary to tell us how big the number is. If it were not there, we would have 0.12 and not 0.012. On the other hand, the 0, this rightmost 0 is significant. So this number would have 3 significant digits. So let's do some practicing. Here we have a multiplication of 0.023 times 1.00. Which answer would have the correct number of significant digits? So pause the video at this point and select one of these responses. Okay, so now that you have selected one of the responses, let's take a look at this problem. So the 0.023 has a total of 2 significant digits. This 0 is necessary to tell us how big the number is, and zeros to the left of the decimal point are not significant, so this 0.023 has 2 significant digits. The 1.00 has 3. These zeros are specifying accuracy. So we have a number with 2 significant digits times a number with 3, so our answer should have 2 significant digits. So we would select C because that answer also has 2 significant digits. Now, one question that students always ask me when we get to this point in the class is, am I going to have to write down answers that always have correct significant digits on tests and quizzes? And my answer to that is, if the question specifies that you must write your answer with the correct number of significant digits, then yes, that's something you need to worry about. Otherwise, for most problems, just write down 3 or 4 digits. So if the problem specifies that you need to worry about significant digits, worry about significant digits. Most of the time, just don't go crazy and write down everything that your calculator gives you. So restrict your answer to 3 or 4 significant digits. We also want to talk about estimation, which is a very useful tool that physicists use in real life all the time. A lot of the time we want to get a ballpark answer for a quantity, and so we follow this procedure for estimation. So first we'll make an educated guess of a quantity, do calculations based on those guesses, and then since we're just making guesses, we're not being terribly precise, we round the final answer to the nearest power of 10. So let's practice that. So this question asks you to estimate your age in months. So you should pause the video here and try doing that. Okay, so let's take a look at this calculation. If we're estimating your age in months, well, first you have to specify your age. So let's say that your age is approximately 22. So then you would write down 22 and multiply by the number of months in a year. So if you're 22 years old, and each year has 12 months in it, then you would get an answer of 264. Now we need to round this answer to the nearest power of 10. 264 is the same thing as 2.64 times 10 to the 2. So we would say that the nearest power of 10 is 10 to the 2, or 100. So if you estimate your age in months, you would get about 10 to the 2. I would not expect anybody to have estimated their age to be 10 to the 0. 10 to the 0 is the same thing as 1, and if you're 1 month old and in this class, you are a genius, but I think that's very unlikely. The same with 10 to the 1, that means you're about 10 months old, and these ages, maybe if you are a bit older than 22, maybe if you're more middle-aged, you might qualify for 10 to the 3rd. 10 to the 4th is getting pretty old, and you look awesome for your age. So that concludes video 5. In the next video, we'll actually be getting into a little bit of physics. We'll be looking at coordinate systems and then the physics concepts of path length and speed.